Good morning, good afternoon, good evening, ladies and gentlemen, boys and girls. Welcome to Emergency Management Associates, coming to you from the Area Command 392 miles west of Kitty Hawk Beach, North Carolina. We want to welcome everybody to our show tonight. As you can see, I'm not wearing oxygen tonight. I had 2 doctor's appointments today. Both of them were fairly decent. Fairly decent meaning I do have some issues, but whenever I can go without oxygen, I'm going to do it. I've been without oxygen now for about 3 hours and I feel great. So we're going to go without oxygen until something else happens, and I'm keeping track of it with this device right here. Right now, my oxygen sat level is very good. My oxygen level is 96. My heart rate is 65 right now. Low heart rate, very good oxygen sat. I'm doing very well. So we're not going to put on oxygen until I feel like I need it. And hopefully that won't be too late. I don't think it will. But I want to tell you guys how good things are. Okay? Things have not been this good in a while. Okay? I've got 2 different doctors helping me, and I feel like I'm a little bit better today. So that's what we're doing. I want to thank you all for being here with us. Grace for Purposes, thank you, Ron, for Bible School video. Learned a lot, answers to my questions, great news, thank you. Also, I want to thank Kim Possible that's in our chat tonight. She was the first one in here tonight. We haven't seen her in a while and want to thank her for being here. God bless you. We appreciate you very much. I want to thank all of our EMA family for being here. Demon Catman. Sleeping Volcanoes also here. Heather is not going to be here tonight. She has some other pressing issues that she needs to take care of tonight. Several other of our mods may not be in here as well. I'm hoping they do come in though. We appreciate each and every one of you for being here. Now folks, there's a lot going on here. I'm not going to be sheepish about this. I'm going to tell it like it is. Guys, I will not be talking politics on this channel for a while, at least. Okay? Another couple people that have been talking politics on YouTube have had their channels decommissioned, taken off the air completely. Someone else was demonetized. I was demonetized last week. This other person was demonetized today. 2 other people were taken off the air. One of them was one of Glenn Beck's best people. He was taken off the air today as well. I don't want to be taken off. I want to keep this channel as much for emergencies and emergency preparedness as I possibly can. So going forward, at least on this channel, you're not going to hear any politics. However, I'm going to open up my Rumble channel again. And I will be going on, not tonight, but probably sometime tomorrow. So I want to tell you that. We will be going on to Rumble. So look for Emergency Management Associates on Rumble. I will be there. But I don't want to lose this channel for emergencies and earthquakes and such. We'll be talking about space weather. We're going to be talking about weather of all kinds, whether it be tornadoes, whether it be hurricanes, whether it be rainstorms or floods or snowstorms. We want to keep this channel for emergencies, and that's what we're going to do going forward. Now, speaking of space weather, we had a solar flare today. A good sized solar flare. Okay? This is where it came from. Okay? It was sunspot 3500 in the center of the sun facing us. This was an Earth-facing solar flare. This was an M9.8, just short of becoming an X-class flare. An M9.8 flare. It occurred from this region here that I'm showing you, okay, this afternoon at approximately 2:50 p.m. Okay, now over here on the bottom left of this slide I'm showing you here, this is the primary area of high frequency impacts. This was an Earth-facing solar flare. This was head-on. And as you can see, this red area, this is very much exemplary of what this flare did to our high-frequency communication system here on this Earth. Now, with that said, our magnetosphere that is surrounding this planet, our magnetosphere is not very strong right now. Solar flares are supposed to be helping strengthen it. But this is the beginning of the solar flare arena. Solar flare 11. Okay? Actually, solar flare 24 just ended, so this is solar flare 25. I mean solar flare. This is the solar cycle 25. 24 ended last year. Okay? We'll be full-fledged into solar cycle 25 the end of this year. So we're not getting much protection from these flares, from the plasma radiation that's striking the Earth. That's why we're seeing so many large and very strong earthquakes. Okay? James Brecka just gave us a $5 super chat. Thank you, James. I appreciate that very much. James says it's time to rumble. Okay? Time to rumble. You guys can find me on Rumble under Emergency Management Associates from every day going into the future when we want to talk about things that YouTube would find offensive. We're not going to give them a chance to knock us around. Not now, not ever. Okay? Anyway, guys, let's go forward here. The entire Earth got hit by a large solar flare today. A very large solar flare. This knocked out high-frequency radio communications. And I'm talking about air-to-ground planes, control tower to planes in the air, aircraft of all kinds, national, international flights. We're talking about aircraft, small commercial aircraft, and public aircraft services. Okay? Their radios were out of service partially, or their communications weren't allowed to go forward because you would hear crackling in the background. Okay? That's what happens. Air-to-ground plane traffic, air-to-ground International Space Station, from Houston or Russia up to the space station, or any other spacecraft that are up in space. We're talking about satellite communications. Whether it's communications verbally or data communications in terms of the GOES satellite system or any other satellite system that's in space. The communications between the Earth and the satellites are disrupted. We have seen satellites be knocked out of space by these CMEs. The last one was earlier this year. This was a big one. Okay? Temporary degradation or complete loss of high frequency HF radio communication signals on the same sunlit side of the Earth where the solar flare hit. Okay? Now, primarily between now and December 1st, we're going to see plasma radiation hitting the Earth. Some radiation has already hit the Earth. Some radiation has already hit the Earth. But this is the beginning. This is the beginning. Okay? We're going to see plasma radiation hitting the Earth between now and December 1st. A lot of plasma radiation hitting the Earth. So, what are we going to see? We're going to see an upgrade, a tick up in earthquakes. It could also affect our weather systems as well. Whether it be snow, thunderstorms, thunder, snow, or anything in between. We could get a hurricane. Right now we don't have any hurricanes on the horizon as of yet. That could change. That could change. Now, I'm not going to talk about a facility that's called HAARP. Okay? Someone on one of our Facebook Messenger chats asked me about that yesterday. I answered their questions about this. This facility here also alters weather. Also alters weather. Okay? So, what I'm saying, between that and the solar flare, things could be a little bit dicey in the days to come. Okay? So you might see larger earthquakes. I'm not going to say even might. You're going to see larger earthquakes. Okay? You may see alteration of weather patterns. That has also been the case. Okay? We're going to see that. Also, don't put that facility that I just showed you on the chat. Please refrain from putting this on the chat. Okay? I don't want to see this on the chat. Please don't put it there. I don't want this channel to be taken down because I'm relaying important, vital information for all of us. It's called emergency preparedness. Okay? That's what we're doing. All right? Now, let me show you what happened today. This was looking directly at the solar disk. The SOHO satellite was looking right at the solar disk. And you can see at the time where this thing was erupting. It was huge. Huge solar prominences launching from the sun. Now I have even more better than that. Watch this. This is a solar prominence launching from that sunspot directly at the Earth, Earth facing. Okay? Wages World. My friend Mark Wages on Wages World here on YouTube will have a broadcast tonight about that. Okay? He had a short that he put up and showed a picture of this solar flare launching. And he said he would be back on the air tonight to talk about it. So guys, when you get the chance after we get off the air tonight, go over to Mark Wages here on YouTube. And I've got a link to his channel on our program description just below this video tonight. You can go over to his channel and watch what he has to talk about. He is a space weather expert. Okay? I asked him if he would like to come on this channel, and I'm hoping he will. I want to have him on this channel to talk about space weather. We're going through a lot of stuff right now, and I think everybody needs to hear it. Kim Posibly says, love wages. I love to hear about that. Okay? I love people talking about our friends here on YouTube. Mark Wages, Mark Pyers, and there's quite a few others. Okay? Please watch Mark Wages a little bit later tonight. Okay? Now, I want to get into Iceland. Well, let's see. Hold on a second. Let me see if I've covered everything I wanted to talk to you about. Okay. In watching that CME that launched, okay, there was actually 3 different eruptions, 1, 2, and 3. Okay? The first collectively arrival could spark a G2 class geomagnetic storm. Okay? Starting on November 30th and into December 1st. The forecast does not yet take into account a possible CME hurled toward us by today's almost X-class solar flare. Okay? It came out as an R9. An R9, which technically is a moderate radio blackout event. But folks, it's a big deal. Okay? An R9.8 at 2:50 p.m. this afternoon. It was measured by the GOES 18 satellite. Okay, I showed you that solar sunspot 3500. It's a moderately complex sunspot group near the sun center meridian. Okay? The high frequency radio degradation is possible over the eastern portion of the southern Pacific Ocean, because the southern Pacific Ocean is where the Earth was facing at the time the solar flare was launched. While it was in progress, okay? When it was first launched, it was an M5 level, but it increased. That's why it's so dangerous. It increased in strength. Okay? It was indicated by the Air Force, U.S. Air Force Solar and Radio Telescope Observatory reports. Okay? The space weather forecasters are examining chronograph imagery as observations become available for CME signatures. That's what they're looking for, a CME signature. But we already know it's a CME. Okay? This is going to be an instability type of region for the next 2 or 3 days at least. Okay? The sunspot will be Earth facing until the end of this weekend. Okay? The chances for further M class, R class, or even an X class flare are very possible. We could get upwards of an X class very dangerous flare. Now, the most dangerous X class flare is an X9. So far, we've only seen X's 1 and 2. I hope that does not become an X9. I highly doubt it. But an X9 is most dangerous. Like I said, we mostly have X1 or X2 class flares. Now, the UV radiation blacked out shortwave radio communications across the South Pacific Ocean and parts of the Southern America area. Mariners and ham radio operators may have noticed loss of signal or extreme radio frequency interference, crackling going on below 20 meters. The explosion hurled a CME towards Earth, directly towards Earth. Okay? We've got SOHO, satellite data about that. Okay? So, folks, we are still waiting for more CMEs from that solar flare, or from that solar sunspot. Okay? So we need to be standing by for that. Now, I want to talk more about what we've been talking about even since 2 weeks ago. 2 weeks ago, on October 27th, 2 weeks ago, Iceland, around Grindavik, Iceland, had a bunch of earthquakes. Those earthquakes were from magma down beneath the surface. Scientists over there and here in the United States have been searching for more information. They've been modeling, computer modeling, and reconstructing the evolution of magma beneath the surface. We talked about the other day a magma dike pushing up from underneath the earth. A magma dike like this. This is what it looks like. Magma dike. Magma pushing up through the earth, getting to the crust. Okay? What we're seeing here is a surface level fissure that opened up there in Grindavik last week. Okay? The data that we're seeing from Iceland suggests that this magma dike could be wider than initially assessed. That could pose a threat. It could pose a threat for a long time period. A very long time period. In an update on Sunday afternoon, the Icelandic Meteorological Office that talks about earthquakes in Iceland talked about a seismic swarm. On October 27th, they were getting seismic swarms totaling 1,700 earthquakes within a 24-hour period. That continued for a long time. Last week, the numbers went down. Even until yesterday, they went down to about 167 earthquakes per day. But those earthquakes went north of Grindavik. We talked about that last night. But those scientists in Iceland and here in the United States are talking about a magma intrusion, indicating an increase in pressure from that magma dike that we were talking about. That magma dike is where the eruption is deemed most likely. Over the course of an hour, 170 small earthquakes were detected, with one, as I reported yesterday, on Sunday, reaching a magnitude 3.0. Up until this weekend, between 1,500 and 1,800 earthquakes a day had been recorded from November until this past week. 1,500 to 1,800 earthquakes a day. Now, last Friday we reported that Iceland was having some adverse weather, and that adverse weather was interfering with the seismic recording equipment, the seismographs. The tectonic activity has seen cracks appear in the ground. These cracks in the ground have prompted local authorities to evacuate the coastal fishing town of Grindavik that sits right on the course of the dike. The magma intrusion, a rapidly forming vertical sheet of molten rock, has formed close to the town on a southwesterly peninsula on Iceland's main island. It's at a weak point in the Earth's crust, as you can imagine. When there is a weak point, magma is able to push up towards the surface more easily. Okay? Now, this weak point in the Earth's crust is estimated to be 9.3 miles long. 9.3 miles long, 15 kilometers long. That's huge. That weak point is very large, which means that a large area could erupt. There's magma, and magma is thought to be a half mile or less from the surface, 2,500 feet below the surface. The seismic office there in Iceland said that the latest burst of earthquakes were measured at a depth of 1.8 to 3 miles deep, 3 to 5 kilometers deep along the dike, with the greatest number occurring to the northeast of Grindavik. The largest number going north from Grindavik. So they're hoping, actually northeast of Grindavik, they're hoping that this indicates that if there was an eruption, most of the eruption would be northeast of Grindavik, so the town could be saved. But judging from this great big huge fissure that opened up, and it's not small, we showed you pictures of it when it first happened, this is bad. But if this continues to go northeast, it would save the town of Grindavik if there was an eruption. Menacing Muskrat says, question is there nickel in the magma? I don't know. I don't know what's in the magma. Nobody has even said what's in the magma. Now, there has been some talk in the previous eruptions over there in Reykjanes Peninsula that is dacite magma. I don't know. I don't know whether that contains nickel or not. I will try to find out. But this horizontal magma has pushed a region around 6 miles, 10 kilometers across, by up to 1 inch to 3 centimeters, which has occurred previously. The Met Office on November 23rd said there appeared to be a strong connection between the uplift, meaning the magma that was pushing up in that dike, with the volcanic reservoir down below the surface that's flowing. The reservoir is flowing into the intrusion. Experts believe that if an eruption were to occur, it would most likely take place somewhere along that path of the dike. Okay? Anywhere from a mile to 13 miles long. That's huge. That's literally huge. The Met Office said that the area with the highest likelihood of an eruption was the middle part of the dike, between the Hagafell Mountain and Sælingafell area, another mountain close to Grindavik. Okay, so that whole area could happen. That whole area, or just a middle portion of that area, could be where the eruption takes place. Okay? Now, scientists are also talking about that the magma dike intrusion was thought to be wider below the surface. What would that mean? That would mean a huge eruption. A huge eruption. This fissure that you see in Grindavik is just a small part of that. Can you imagine if that fissure erupted out there north of Grindavik and it was a larger area of magma beneath the surface, that's what they're talking about. It could be a huge eruption. We don't know. It's being estimated that it would be maybe a few months before the magma had intruded into the dike. And that could solidify. If that magma stays beneath the surface where it's at, it could solidify in that dike, and it would turn into a volcanic rock, a plug in that dike. Now, if the pressure from that magma reservoir beneath that lava plug were to get so great, it could push that lava rock up through the surface, and it could erupt. It could erupt. That is precisely how eruptions have happened in the past at volcanoes. The strength of the magma underneath the plug of the volcano shatters those plugs or pushes them completely out of the way. Okay? Authorities in Iceland have now built walls around the conduits and the canals around Grindavik and Svartsenga, which is a nearby geothermal power plant. They have completed those walls now. Okay? They built those walls around that area trying to be able to direct the lava away from the buildings in the event of an eruption. Why? Those buildings and that canal, the canal brings water to the various cities throughout Iceland. Those channels provide water and heat to the citizens of Iceland. So that's why they built that wall, to try to protect their thermal energy, both the heat and the water. That way people would continue to survive in the event of an eruption over there in Grindavik, Iceland. Does anybody have any more questions about what I just explained to you? Dee Dee is saying, I imagine that lava is quite heavy. Don't know if walls would help. That's true. If that magma dike was anywhere near these walls, it could push up the walls and break it into a million pieces. But if that magma is far distant and those walls had foundations beneath the surface, maybe those walls would be sufficient to hold that magma back. That's what they're hoping for. That they built those walls sufficiently deep into the ground so the walls would have stability to maybe protect those canals and also the geothermal power plant there. Okay, that's what they're hoping. Rochelle D is asking, when is the last time this erupted? Sorry, if you already answered that. Are the canal waters heating up? Yes, they were. Yes, they were, because magma down beneath the surface was heating up the earth beneath the canals. So yes, that has happened. That's happening over in Texas, by the way. Okay? I was over at Texas A&M University many years ago, and I was staying at a 4-star hotel. And I had to put bath water in a tub at 9, 10 o'clock at night to cool off sufficiently so I could take a bath or at least shower, throwing water up onto my body. Because I couldn't turn on the shower on the wall because it was scalding hot coming out of the shower, even at the coldest setting. And that's what happens here. Okay? So no, this is not a bad question. It's a good question, Rochelle. When was the first time or last time it erupted? Last year. Last year. It's been constantly erupting since 1700. This volcano over there has been constantly erupting since 1700. Okay? The last eruption was south of there, south of Greenvik, just a year ago. The magma hole, there's a magma hole that is down beneath the crust of this earth. And as our tectonic plates move, let me take down this picture here. I want to explain this to you so you understand. As we have tectonic plates moving, the magma plume is staying put. The plate is moving. Where the plate is moving opens up a new spot if the earth right there is allowing or soft enough, it allows that magma to intrude in that area. And if the magma forces its way up, there's a powerful magma plume there. Okay? And it forces its way up. The Atlantic plate is moving. The Atlantic plate is pushing the North American plate, Canada and the United States, in a south-southwesterly direction. That's why we've seen earthquakes up and down the coast of the United States and Canada. And those earthquakes continue to happen. That is exactly what's going on over in Iceland. Except, we've shown you a map of Iceland. The Atlantic plate traverses through Iceland, almost slicing it completely in half. Not quite. That Iceland, or that Atlantic plate, is moving in two separate directions. The eastern side of the Atlantic plate is pushing the tectonic plate eastward. The western side of the Atlantic plate is pushing southwestern, in a southwesterly direction. It could break apart. It could force Iceland to be broken in half. And with that magma down there, who knows what can happen? It's literally almost like a crapshoot. Nobody knows. It's never before happened. We've never seen anything like it. But folks, it's happening. It's happening. The scientists and everybody else in Iceland knows what's going on there. They know their country is hovering over a tectonic plate, and that tectonic plate is expanding. It could rip Iceland apart. It really could. Do you have any other questions about Iceland or that volcano over there? These are all great questions. Don't think of anything as stupid. They're not. These are very important questions that everybody deserves answers for. And there are not too many people like me giving you the information. Again, I've studied this. I've studied it back in high school, I've studied it in college, and I continue to study it and gain information. Okay? If I was to say that I have my degree and I don't need anything else, that would be stupid. I know I need additional information, and I seek for it. I've been pulling information together for years and years, and I continue pulling information even today. That's why I know what I know. I'm not the smartest tool on the tool belt, but I have sufficient knowledge, and I continue to seek for more, which makes me almost dangerous. Okay? James Barreca says he has his eyes on Venezuela right now. Venezuela is having earthquakes. How many of you have seen the earthquakes in Venezuela? Not too many. Because the United States Geological Survey isn't showing the earthquakes. Heck, they're not showing much going on in South America at all. None. Almost virtually none. Let me show you something. Okay? I pulled this information earlier today. Now, before we leave here tonight, I have some things that I need to share with you about some of our family members here on EMA. So please don't let me forget to show you, or not show, but talk to you about what's going on in some people's lives. I have in one case been asked to talk about it, and I'm going to talk about it. Okay? Now, before I get into these earthquakes and such, I want to show you this. This is what Mark Pyers put up earlier today. NOAA and NASA's incidents and models, the computer models, confirm multiple hits on the way, multiple CMEs on the way. He says, I will keep you up to date for a live stream later today for an update. God bless and have an awesome day. That's what Mark Wages put up. NOAA confirms, and NASA also confirmed the information. And Mark, like I said, Mark Wages will have an update later this evening. Now, when you talk about, or when we talk about earthquakes in South America, look what we have here. Look at all these earthquakes all around the western side of South America, and even north of there. Okay? Even north of there. Look at the earthquakes. These are just not 2s and 3s. There's a lot of moderate 4.0s and 4.5s, even upwards of a 4.8 occurring over there in South America. And USGS is silent. They're showing 3 earthquakes on the USGS feed. Now, also look at Central America here. Look at the earthquakes there in Central America. USGS is not saying word 1. They're showing an earthquake over south of Panama. An earthquake south of Panama of 4.3. That's fine. That's all fine and dandy. But that's not the only earthquake. There's a bunch of them. There's a bunch of them. Look at the earthquakes in the Middle East and Europe. Okay? This is what I'm talking about. This is exactly what I'm talking about, guys. The agency refuses to show you that information. Look what's going on down there in Indonesia. Indonesia and Papua New Guinea. Okay? Last week, on Sunday, we had this 5.0 large earthquake happen over there in the eastern Indian Ocean, just south of Australia. It was on the Antarctic Ridge. On the Antarctic Ridge. Also over in Vanuatu, Fiji, Tonga, and the Kermadec Islands, and even in New Zealand, we're having earthquakes. Who would have thunk? Who would have thunk? Look over here around Taiwan and Japan. Look at those earthquakes. Those earthquakes in yellow happened today. The earthquakes in orange, you see that 5.0 in orange? That happened yesterday over in the Mariana Islands. Okay? Even further north, over here in the Kuril Islands here. Okay, 4.0 and 4.7. That 5.0 in the Kuril Islands happened yesterday. Okay, the Kuril Islands are between Hokkaido, Japan, and Kamchatka, Russia. The Kamchatka Peninsula in Russia, right there. Okay? Jamie Wilkie is asking about Washington, Seattle. I'm going to give you a complete report about what's going on around Washington and Oregon in just a couple minutes here. Okay? Now, USGS was not even reporting this earthquake at 2.4 in Northern California. They were not even reporting this earlier today. It happened at 10:47 a.m. Notice that they were not showing anything over in Seattle or Oregon, Washington or Oregon earlier. Not a thing. This is what I'm talking about. This is exactly what I'm talking about. Okay? Spinderella says, I'm not crazy about the human race, but you're one of the few I love and admire. You are a true blue. I'm trying to. Okay? I'm trying to be that way. I'm not perfect, but I'm trying to be that way. Intrinsic Factor in the chat is saying a few years back, USGS deemed the Cascadia Subduction Zone corridor from Vancouver to Portland the most dangerous place to live on the planet. It is. From Vancouver Island south, even, and I'm going to say, all the way down to Mexico. I'm going to say all the way down to Mexico. Why am I saying that? Can anybody even think why I would say that that's probably one of the most dangerous corridors to ever live in? We've talked about this before. This almost should come to know, not to even be a surprise to any of us that have been looking at what's going on along the west coast of the United States. It should not come to most anyone's surprise about what's going on. Now, I just brought up the map of the map of the world here, okay? I'm just going to move this here, and I'm going to talk about the Pacific Northwest tonight. I have seismograms to show you. I actually have seismograms to show you to prove what's going on, because the agency is not talking about it. They're not being honest about it at all. We have to go into the seismograms to pull information. Notice here on the USGS map. A few minutes ago, I showed you a map with a lot of earthquakes here. There are a lot of earthquakes. USGS not talking about it. They're showing us one 5.3 in the Tonga region. The southern Tonga region right there. A 5.3 earthquake. 6.2 miles deep. 10 kilometers deep. Over here in the southern Fiji region. This is a 4.6 moderate quake. USGS wants to call this a light earthquake. USGS changed the parameters about 3 months ago. A light earthquake is not a moderate 4.5 or 4.6 in this case. Folks, 4.0 to 4.9 were considered to be moderate earthquakes. Now USGS has grouped them into light, meaning if they hit in a populated area, there's light damage. They're wrong. If a 4.7 to, well, even a 4.6 to a 4.9 hits a populated area, it's not just going to be light damage. There's going to be moderate damage. Pictures falling off walls, cracks opening up in walls, furniture moving, knickknacks and books falling off of shelves. Moderate earthquakes. Large earthquakes are 5.0 to 5.9. USGS has grouped them into what? Moderate. Moderate. Anyone that has seen or lived through a 5.0 to 5.9 earthquake would not say that. I have lived through those earthquakes in San Diego and also up in Los Angeles. I've seen not moderate damage like USGS would now have us believe. I've seen a lot of damage. I've seen people killed in a 5.0 earthquake. I've seen people killed in a 5.6 earthquake. I don't in my heart believe that they could name a 5.6 earthquake a moderate earthquake when it causes a lot of damage and can kill people. Yes, a 4.0 to 4.9 could actually kill someone if the building materials in the buildings or homes that they're in are not built correctly. Their homes could collapse around them. Or say we have a big enough earthquake that opens up a fissure in the ground. People could fall into that fissure and get killed. We've seen large, long fissures open up in Turkey. In Antarctica, 12-mile long fissure in Antarctica 3.5 years ago. We've seen a 14-mile long fissure opened up in Turkey, in the Syria-Turkey area, earlier this year, after 9.0, 10.0 earthquake hit, that they tried to pass off as a 7.4 major earthquake. I've not seen a 7.4 major earthquake open up fissures before. Again, they can lie to people as long as they want. They can lie to people and call a worm a snake, or call a snake a worm in this case. It depends on how bad the bite is. How bad the bite is. Okay? Earthquakes can kill people. That's why I prefer to tell the truth about what's going on. Over here near Levuka, Fiji. Okay? Here in Levuka, Fiji area. This is a moderate 4.5 earthquake. This happened out here in the ocean. Okay? Nowhere near land in this case. This is a 360-mile deep earthquake. 360 miles deep. Folks, this 4.5 earthquake is going to propagate a 5.5 to 5.6 large earthquake within the next 3 to 10 days. It could happen here in this same area. Yes, it could go south. It could go south down here into in the southern Tonga region. It could continue south down here in the Kermadec Islands north of New Zealand, or that earthquake could hit here in northern or in the southern island of New Zealand. We saw a 5.0 earthquake hit down here about 2 weeks ago. Okay? Just 2 weeks ago. This other earthquake that I showed you here before I showed you the Luca Fiji earthquake, this earthquake 4.6, folks, it's also 340 miles deep. 500 plus kilometers, I think it's 560 kilometers deep. 560, 570 kilometers deep. Folks, this could also generate a 5.6 to 5.7 large earthquake, a mid-range large earthquake. That earthquake, again, that seismic energy could go north. It could go north in Hawaii, go north into the Aleutian Island chain. It could go west over here into the Solomon Islands or Vanuatu, or even into oh gosh, I can't remember what I was gonna call them, down here in the South Pacific, south of Fiji. It could go there. Go over here in the Vanuatu area too. This is a 5.8 very large earthquake. 5.5 is the medium area of large. A 5.8 is a very large earthquake. Okay? This happened in the Vanuatu region. It happened for the most part away from land. It's out in the Pacific here. The nearest land is miles south of here. This is a very large 5.8 earthquake. They say that this is 6.2 miles deep, 10 kilometers deep. Now, USGS for some reason has reevaluated their depth to earthquake ratios. They said that a 6.2 mile deep earthquake that they put out could not necessarily mean it's 6.2 miles. They have openly come out and said that a 6.2 mile or a 10 kilometer deep earthquake may not even be known exactly how deep it is. We have seen too many 6.2 or 10 kilometer deep earthquakes. We've seen these very shallow earthquakes hit all over the earth. For the first time in our history, I personally have never seen so many shallow earthquakes with a depth of 6.2 or 10 kilometers deep. Never. They have always told us how deep these earthquakes really are. Now they're rescinding on that. Okay? They don't want to tell us because they know darn well that shallow earthquakes propagate, I'm sorry, not shallow, deep earthquakes propagate more shallow, stronger quakes. More shallow and stronger quakes. So maybe they're not wanting to report on depths because they know darn well that there's going to be stronger quakes coming. Now, those stronger quakes are more dangerous when they're at a lesser depth. Okay, this was a 5.8 earthquake. It could be a very dangerous earthquake if it hit land. This was out in the ocean. There was no tsunami with this earthquake. We need to make sure we get the information out. There's probably not going to be a tsunami unless there's a 6.0, 6.5 earthquake out in the ocean. If there's a 6.0, 6.5 on land, it's highly unlikely that that would cause a tsunami. If it's out here in the ocean, it's a possibility. Now, lately, we've seen a lot of very large earthquakes, and I'm going to say very strong 6.0, 6.5s, even some 6.8s that have not caused a tsunami. We've just gotten lucky. We just got lucky because it could very well happen, and it has happened in the past. Let's go west over here into Papua New Guinea. Okay, over here. We've seen some very strong earthquakes here. We've even seen 7.2 to 7.4 earthquakes over here in the same area here at Papua New Guinea. This is a 4.6, 119 miles deep, a 4.6. That was an aftershock from this earthquake, which was a large 5.0. Both of these are aftershocks of earthquakes that happened here 2 weeks ago. 2 weeks ago. 6.8. 6.4. These two earthquakes are aftershocks from that stronger earthquake that hit here 2 weeks ago. Okay? Let's go over here. Again, this is in Papua New Guinea. These earthquakes are straight in line. What does this tell you? Earthquakes that are straight in line, whether they're vertical or horizontal or perpendicular, it doesn't matter. The energy is moving. The energy is moving. Again, we've had 5.5, 5.8 earthquakes in this same region over the last week. These, I believe, are aftershocks from that earthquake. I shouldn't say though, just that earthquake, several earthquakes. These are aftershocks of several earthquakes that have hit in this region here. Okay? This earthquake here, okay, just want to tell you about it. This is a moderate 4.8. Okay, this is the upper 4 that I've been talking about. We used to say moderate damage. Guess what? A 4.8 is a very strong quake. It's not a 6 to 6.9 that you normally call a very strong earthquake. But this is a moderate 4, 4.8. This could cause damage here. All it would have to have is people that lived in this area. Now, from my perusal of this area, I don't believe there's anyone living here. This is a tropical, subtropical area. Okay? A forested area. A 4.8, 6.2 miles deep. The one north of here, up on top of that ridge. Okay? The ridge is the edge of the plate. This is a 4.6, 43 miles deep. This one up near the coast is a 4.6, 64 miles deep. Okay? This one down here to the south, 6.2 miles deep, compared to this one being 64.5 miles deep. That's a difference here. That's a difference. Okay? Going up here, this is over in northern Indonesia, Halmahera, Indonesia. When was the last time I mentioned Halmahera, Indonesia? Yesterday. Yesterday, guys. Halmahera, Indonesia is where Dukono Volcano is. Dukono Volcano. This is an aftershock. This is an aftershock of a much larger earthquake, a 5.2 earthquake here. A 5.2 large earthquake, 6.2 miles deep. A shallow, large earthquake, just off the coast of Halmahera, Indonesia. Nobody felt this quake. Look where it occurred. Right on top of that earthquake fault. If you have been with this program for any time at all, you'll understand these earthquake faults here are plates. There are 7 different plates here. 7 different plates that are moving. Each plate is subducting under the other. Each plate is subducting under the other. The Indo-Australian plate is the largest plate here. But 7 different plates are being subducting here. Why do you think we have so many volcanoes? 9 chances out of 10. If the area is not subducting, there won't be that many volcanoes at all. In order for there to be active volcanoes, the area must be subducting. And that's what's occurring here in Papua New Guinea and Indonesia. A little bit earlier, I showed you all the earthquakes that are occurring here. USGS has shied away from that during the last year. They're hardly showing anything anymore. This earthquake that I just highlighted here is east of Java. This occurred in Labuan Bajo, Indonesia. Labuan Bajo, Indonesia. This was a moderate 4.5 here. 177 miles deep. A fairly deep earthquake. Now, I also showed you what's going on here in this area here and upwards north into Japan. There are a lot of earthquakes here, but again, the preeminent earthquake agency, the preeminent seismic agency for the world, refuses to report what's going on. And they accuse the other agencies of not reporting information. I'm sorry, the other agencies are reporting it, but the European agency and the USGS are backing away. USGS, huge walk away from it. EMSC is backing away also. Okay? This is showing a 4.5 earthquake down here in the Ryukyu Islands. Folks, a 4.5, a 5.0, and a 4.7 earthquake are right in this area. Okay? This shows a 4.5, 66 miles deep. Earthquakes over here east of Japan. They're not reporting any at all. Over here north of Japan, north of Hokkaido, north of Hokkaido. Hokkaido is the northernmost island here in Japan. There is an earthquake just off the northeast coast. This is a 4.6 earthquake. Folks, this happens to be 76 miles deep. 76 miles deep. 4.6. Further north, also in the Kuril Islands here, is a large 5.1. There are a couple other earthquakes here that they're not showing us because they believe they don't have to. Over here in the Rad Islands, Adak Island area, there are small minor earthquakes here. We go further east in the Aleutian Island chain. This, folks, is a 4.3 aftershock, 23 miles deep. A 4.3 moderate aftershock. It's only moderate because this was a 5.6. This was a very large 5.6 earthquake. Also 16 miles deep here. 16 miles deep here in the Aleutian Island Trench. Okay? Now they're not showing many earthquakes at all here in Alaska. They want us to believe that nothing's happening. Well, golly gee, folks. Now they're showing more. Earlier today they showed 9 earthquakes around here. They are showing more, but there's a lot more than that. Just briefly, over here in the center of Denali National Park, Skretna, Alaska, supposedly. Folks, Skretna, Alaska is nowhere near here. This is in the center of Denali National Park. This is a 2.1 earthquake that just happened. A 2.1 earthquake that just happened. One more earthquake that I want to show you here. This is a 1.4 here in Denali National Park. USGS is calling this 37 miles north of Petersville, Alaska. Folks, USGS, call it like it is. It's in Denali National Park. Denali National Park. Okay? They still cannot get over lying to the public. South of Anchorage, we have this earthquake here. This time, they say it's south-southwest of Anchorage. It's actually directly south of Anchorage. Anchorage is that town right here that you see here. This is a fairly large city here in Alaska, Anchorage. This earthquake is a 1.6 tremor here, south of Anchorage, not south-southwest of anywhere. It's south of Anchorage, period. Okay? And again, they're not showing much of anything here, which is a fallacy. It's a pipe dream. Notice what they're showing us here in Washington State, just east of the Puget Sound. East of the Puget Sound, they're showing us a 1.0 tremor here. 1.0 tremor, 15 miles deep. Okay? That's what they're showing us. They're not showing us anything over here at Mount Rainier. They're not showing us anything here at Mount St. Helens. They're not showing us anything down here at Mount Hood. All 3 volcanoes. I'm coming back to those in just a second. Over here in the south central part of the Cascadia subduction zone, off the coast of Northern California, we have a 2.0 earthquake. A 2.0 earthquake 3 miles deep on the Cascadia subduction zone, look where it's at. On the Cascadia subduction zone. Well, glory be, they're actually saying kind of where it's at. USGS is saying it's off the coast of Northern California. That's right. But it's on the Cascadia subduction zone. Again, they're not telling us exactly where it's at. Okay? There's also earthquakes off the coast of Ferndale, California here. Off the coast of Ferndale, California here. Just east of the Cascadia subduction zone. North of the San Andreas Fault, which starts here at the junction of the Cascadia subduction zone and the Gorda Escarpment. That earthquake fault that runs west from California, that's the Gorda Escarpment. The San Andreas Fault connects at the triple junction here and starts its way through California here. Okay? We have one earthquake here. I just want to briefly show you this. Navarro Head, California. This is a 2.1 earthquake. Just for kicks and giggles. San Francisco Bay Area here. On the Hayward Fault. This is a 1.4 tremor on the Hayward Fault. Orinda, California. Or Orinda, California, I believe they want to be called. Just over 3 miles deep. Also on the Hayward Fault here. This is a 0.7 microquake near San Ramon, California. On the Hayward Fault. South of there, the San Andreas Fault. Here, Loyola, California, 1.0 tremor. East of there, on the Hayward Fault, we have a 0.8 here. Alum Rock, California. Notice where this earthquake is, the one over on the San Andreas Fault. And just east of there we have the Calaveras Fault. Today they're not showing us any earthquakes. These 3 earthquake faults, one on the east side of the hills away from San Ramon. Okay? East side of there is the Calaveras. These are 3 of the most dangerous earthquake faults in the world. 3 of the most dangerous earthquake faults in the world. Okay? I just want to show you that. One more. Southeast of Monterey Bay. Tres Pinos, a 2.0 earthquake on the San Andreas Fault. Over here, this is a 1.0 tremor here. Tres Pinos. Okay? Notice where those are. 2.5 years ago, we had a 5.1 here that caused major damage to the city of Tres Pinos. And there was a huge fire from damage as a result of that earthquake at an oil refinery in Tres Pinos, right next to the Interstate 5 highway. Okay? So USGS wants to call 5.0's moderate quakes major damage. Major damage with a 5.1 earthquake. Okay? Do you hear what I'm saying? Do you see what I'm saying? East of there, this is Nevada. This is just east of the Walker Lane Fault. This is a 2.0 earthquake. A 2.0 earthquake here. Okay? One other earthquake here, and then we're going right back to the Pacific Northwest. This is Tehachapi. Tehachapi. It sits here on 2 different faults. The San Andreas Fault and this Garlock fault here. This case is just north of the San Andreas here in Tehachapi on the Garlock fault. We have a 1.0 tremor here on two different faults near the San Andreas, but on the Garlock. The Garlock fault runs from at the San Andreas junction point all the way up into the Mojave Desert, where we have Ridgecrest, Cyril's Valley, Cozo Volcano, guys. Ridgecrest up here, a 1.6 tremor here. 1.6 tremor. This is Trona. This is west of Trona, California here. This is a 0.8 microquake. A 0.8 microquake. Up here to the north, this is Cozo Junction. Cozo Volcano. Cozo Volcano, a 1.6 tremor here. Folks, they want everybody to believe that nothing's happening here. Folks, there's a half dozen earthquakes up here at Cozo Volcano. Linda just gave us a $20 super chat. Thank you, Linda. God bless you. Thank you so much for that. She says, God bless you and Carol. We appreciate that, Linda. God bless you. Thank you so very much. We appreciate that greatly. Okay? Thank you guys for supporting this channel. We appreciate it. You can also support us over on the PayPal and Venmo locations we have set up. They're also down in the top of the program description, just below this program today that you're watching here. Let's go back to the Pacific Northwest, where they're not showing anything going on. Literally nothing going on, right? Guess what? There's a lot more going on than they want us to show you. So we're going to show you guys for kicks and giggles. I want everybody to know what's going on. This is Mount Rainier, guys. This is Mount Rainier today. Okay? This is, actually, I'm sorry, this is Mount Hood. I didn't mean to start with Mount Hood, but this is just what showed up here. I'm sorry. I'll get to Mount Rainier in a minute. This is the southernmost part down here in Oregon. I'm not going to show you all the volcanoes, but I want you to know what's going on. There's activity at every one of these volcanoes from Mount Shasta, or actually Mount Lassen north. A lot of magma going into the volcanoes, causing a lot of earthquakes. Here at Mount Hood, look what's going on. Look what's going on. They don't want us to see what is happening. Okay? I want to show you this. This seismograph started recording information at midnight last night, early this morning. It's not showing us much of anything. It's showing us a bunch of tremors for the most part, except for one earthquake. That earthquake happened just after 5:30 this morning. Approximately 5:31 this morning, it shows a 2.3 earthquake over here on the left. 5:31 this morning, a 2.3 minor earthquake. Okay? Then, I believe they turned up the seismograph, because all of a sudden, over here on the left-hand side, it says 7:15. 7:15 a.m. Look what happened after 7:15. The seismogram shows minor, very tiny tremor activity happening, and it increases here. It increases here until it gets to be 7:26 this morning. 7:26 this morning, we have an earthquake here. This earthquake is in terms larger than what they're showing here. Why do we know that? Because, folks, you see this earthquake is thick. It starts off with tremors here. It gets larger and larger tremors. Then all of a sudden, the tremors begin into a 2.0 earthquake. The magma is pushing these earthquakes. Okay? We see magma turning into tremor activity because magma is causing rock fracturing inside the volcano, in the volcanic chamber. So we see magma coming down here, we see tremors building with it, then all of a sudden we have a 2.0 earthquake, and it lasts a little while. Meaning we had multiple 2.0 earthquakes. Now they may have been larger, because again, this seismograph has been turned down. Then all of a sudden here, we have what appears to be a 2.7 earthquake. A 2.7. This earthquake here looks like there's multiple earthquakes. Of course there are. In order for that earthquake to be as large as it is, it lasts a period of time. Probably 10 seconds. Multiple 2.8, 2.7 earthquakes here. But folks, I'll bet it's larger. I'll bet this is a 3.5 earthquake. Why do I say that? Look at what goes out to the right after this main earthquake. After the primary waves of that earthquake happen, we have secondary waves. All of a sudden, for about 20 seconds, we have secondary wave here. That secondary wave is like a 1.6, 1.7 tremor. Then all of a sudden, the agency stops it for a second or two. Then it starts up again. That secondary wave lasted almost 2 minutes. That secondary wave lasted almost 2 minutes. Then we have a body wave after that. Folks, this is not a 2.7, 2.8 earthquake. This is more like a 3.5. At least a 3.5. It might be even larger than that. They're trying to hide it. They're doing a very good job trying to hide it. But anyone that knows about earthquakes and seismic signatures can very well tell that this was a larger earthquake this morning. Okay? Then, this afternoon, what happened? Look at this afternoon. Again, this is at Mount Hood, guys. What's going on at Mount Hood? Okay? Just before 3 o'clock. 3 o'clock would have been 1500 hours over here on the left. They're showing 1445, which is 245. They're showing 315, which is 1515 hours. 1515 hours. Okay? What's it showing? Over here on the dark blue line here, you're showing seismic energy building up. Magma infill going on here. Pulsed magma activity. PULSED. Pulsed magma activity. The magma level increases here. It decreases a little bit, and then it increases in a large manner on this dark blue line. We see these vertical lines along the top of this magma increase here. Okay? Then out of nowhere at 3 p.m. it's gone from magma, a large amount of magma coming into the magma chamber, which is causing tremors here, and all of a sudden, out of nowhere, we have larger earthquakes. just by what they're showing here. The size would be about 2.3, 2.4 earthquakes. But we already know from looking at the other earthquake earlier today that this seismograph has been turned down. Look at the earthquakes here that it is showing us here this afternoon at Mount Hood. First, we see maybe a 22.3 earthquake, but it lasts about 7 to 10 seconds. Then it goes down a little bit, and yes, we have other earthquakes between it. Then we get to another thick earthquake, meaning the earthquakes were happening back to back to back here. Multiple earthquakes here. Okay? Look at the tops and the bottoms of the seismic signatures. They're cut off. The seismic signatures here, all three of them, are cut off. Brothers and sisters, ladies and gentlemen, these three earthquakes here today were cut off. They're larger earthquakes, probably pushing 3.5, maybe larger than that, at Mount Hood. You can see the secondary wave out to the right. What you're seeing here are primary waves. Primary waves. The secondary wave out to the right are lesser seismicity. Lesser seismicity. So we see a decrease in seismicity out to the right. That decrease happened over like 3 minutes' time. Then on top of that, to the right, we have a body wave, which means this whole earthquake sequence is larger than what they're showing here. The seismograph has been turned down here. The seismograph has been turned down here. We go down here to 1745, 5:45 this evening. We look over to the right. We have an earthquake about 5:58 p.m. It shows us that it might be a 2.1, 2.2 earthquake. But again, we know that this seismograph was turned down. We also see a secondary wave out to the right. It's not a big deal, though. The secondary wave might have lasted about another 10 to 15 seconds. That would even make this earthquake larger than they're saying it is. This might look like a 2.2, 2.3 earthquake, but I will bet you dollars to donuts that this earthquake was at least a 2.8, 3.0 earthquake. Just that earthquake alone. Then we come down to here, what happened this evening. Look at this at Mount Hood. This is indicative of major magma activity at Mount Hood. We show magma coming into the magma chamber, and it's obliterating the hour lines here. Each individual horizontal line here is 15 minutes long. Look how long the magma obliterated those lines here. An hour, hour and a half time period. That is a lot of magma here coming into Mount Hood. Probably some of the largest magma activity that we've ever seen here at Mount Hood. Okay? That's to the south. Okay? Down in northern Oregon. Mount Hood is near northern Oregon. Okay? That's Mount Hood. Let's go up to Mount St. Helens. Now, I'm primarily going to use Pacific Northwest seismic network seismograms to show you what I'm showing you here. Okay? I want to make sure you understand what we're seeing here. The first one I want to show you is East Dome, Mount St. Helens, right here. Again, this seismogram comes from the Pacific Northwest Seismic Network. East Dome, Mount St. Helens. The code name, EDM. Okay? EDM. Now, I want to show you something that appears here. Okay? Early this morning we have some tremors here, right? Looks to be small tremors. Oh, by the way, and I'm joking here when I say that. By the way, what else do we have here? A magma churn signal here. A magma churn signal that appears just after 6:48 this morning. The magma churn signals, as we've explained on previous episodes of this program, the magma churn signals usually are and can get to be as tall as 23 to 24 lines high. Let's look at this magma churn signal and let's find out how much the magma or the seismograph is turned down. Let's count the number of lines that this magma churn signal is encompassing. Down at the bottom we start 1, 2, 3, 4, 5, 6, 7, 8, 9 lines high. This is 46% of real world. This seismogram is showing us 46% of real world. So the earthquake activity here, the earthquake activity that we're showing is over twice the size than what they're showing here. I just showed you the USGS map. Okay? It's not showing any earthquakes at Hood. It's not showing any earthquakes at St. Helens, and it's not showing you any earthquakes at Mount Rainier. But what do we have here? What do we have showing right here? Okay? This happened just after 10 o'clock this morning. Okay? Just about 10:45 a.m. this morning. See this horizontal line here? This is magma coming into this magma chamber. Okay? Now, if that had originally happened, okay, as it shows here, it's showing that the magma started at 10:45 here. Folks, magma just doesn't start like this. So this line supposedly showing magma here at 10:45 a.m. this morning is non-existent in reality. Okay? Why do I say that? We have to go above that one, a line above that one. It shows nothing. It shows us nothing going on here at Mount St. Helens from 10:30 on. It's almost showing us nothing after that magma churn signal. That magma churn signal, guys, happens only when there's a large amount of very hot, scalding magma, 2,500 to 5,000 degrees Fahrenheit. That's what causes magma churn signals. Off to the right of that magma churn signal, those horizontal lines or vertical lines here are caused by steam being released from the magma. Those are steam signatures after the magma churn signal. But folks, what do we have here? What do we have here after 10:45 this morning? we have a good sized earthquake. Where did it come from? Folks, in most cases, this would come from magma coming into the volcano. We've already shown you that this magma here, that is shown here, this magma line, is not incoming magma, because they didn't show it on the line above it. To have this kind of magma coming into the magma chamber to cause this kind of earthquake didn't happen then. It may have been larger than that to cause this earthquake at Mount St. Helens today. Okay? This earthquake happened at Mount St. Helens at about 10:51 this morning. This, folks, is a lot larger than what they're saying it is. Notice the top and the bottom of this earthquake has been cut off. This earthquake lasted at least 10, maybe 15 seconds. Okay? How large was this earthquake? Folks, just what we have here. This would be a 3.0 earthquake at least. At least. They've cut off the bottom and the top of this. Folks, if we put dollars to donuts, what do we have? Probably close to 4.0, maybe even larger than that. Why do I say that? Because look at the secondary wave. That seismic energy going out to the right. That secondary wave lasted how long? Folks, that secondary wave lasted nearly 3 minutes. 2.5 minutes. 2.5 minutes. Folks, this earthquake, that original earthquake here, probably a 4.0, even maybe a 4.5. Because that secondary wave lasted 2.5 minutes. That's a big deal. Then out to the right, we see more magma. This, folks, might be reality, because we see sporadic magma. Magma pulse signals. Magma pulse signals. Magma pulse signals. Because the magma dissipates some and builds up again. That's what we're seeing here. Magma pulse signals. Okay? I want to show you something really briefly. Okay? Let me take this down really quickly. Okay? I want to show you something. This is my pulse oximeter. The top of this says 95. That's the amount of oxygen my body's receiving. My pulse rate is fairly low, 83 beats per minute. Okay? It could be lower. Usually it's about 65 to 75, but I'm talking to you, and yes, I'm getting a little bit animated because of what I'm showing you here. Okay? But it's important. These earthquakes just didn't happen by themselves. Okay? Over here on the left-hand side, look what's happening after 11 a.m. Okay? We show these thin lines here. Thin lines is lesser magma coming into the magma chamber of Mount St. Helens. But I believe they turned it down again. Because, why? That earthquake that we had here just after about 11:51 this morning made its way through the seismograph turn down. The seismologist turned the seismograph way down. The energy of that earthquake made it through the turn down. That's what we're seeing here. That's what we're seeing here. Now you see 4 lines after that. Very thin magma. However, over on the left-hand side on the black line there, The black line would signify 11 a.m. this morning. Look what we're seeing. Tremors. Tremors making their way through the turn down of the machine. Okay? The magma coming into the magma chamber is causing rock fracturing. That's why we see those tremors here. As we go off to the right, okay, it doesn't show much. Over here on the right, just prior to 11:15 on that black line, about 11:13, 11:14, we see the magma building up. Pulse magma signals. Pulse magma signals. And they continue. 11:15, and all of a sudden, at 12 noon, what do we have here? On that black line at 12 noon, what's happened here? Again, we start seeing false magma infill signals, false magma pulse signals, okay? But all of a sudden we see tremors again. So we know there's magma coming into the magma chamber here at Mount St. Helens. Then again, over here on the far right, this is 12:13 this afternoon. Again, we have an earthquake, don't we? The top and the bottom of this earthquake have been cut off. Again, this is a 3.0 earthquake. Supposedly. A 3.0 earthquake, supposedly. It's been cut off. They would say, oh, but it was cut off, meaning it didn't happen. Yes, it did. This also was a much larger earthquake. Off to the right of this, what do we see? We see a secondary wave that lasts 2 minutes. Then we see another earthquake off to the right of it, just after 12:29 p.m. today. That earthquake was also had the bottom and the top of it cut off. In this case, there's very little secondary wave here. This may have been a 3.0 earthquake, considering we've already had at least, okay, on this earthquake sequence here, to the right here, this, folks, was at least a 4.5, maybe larger than that. A 4.5 earthquake that caused a secondary wave lasting 2 minutes. That's what we're seeing here. Then we come back over here to the right. Okay? First, we see a black line here. This is 3 p.m. 1500 hours this afternoon, 3 p.m. Folks, we don't see anything after that. Okay? They cut it off. They cut it off. Why? If this seismogram covers what it usually does from 5 p.m. to 5 p.m. Monday through Friday, Saturday and Sunday, the seismogram is supposed to run 24 hours. Why did they cut this off just after 3:30 this afternoon? At 3 o'clock, you see that black line here. Look at the earthquakes here. Back to back to back earthquakes, just like we've seen all day long here. Okay? Back to back earthquakes. This first earthquake here on the black line lasted at least 60 seconds. Look at the number of earthquake signatures here. Back to back to back. 1, 2, 3, 1, 2, 3, 1, 2, 3, back to back to back. Okay? Probably, and I'm going to say, probably 3.0 earthquakes. It could have been larger than that. We don't see the bottom of it. We don't see the bottom lines here because it's cut off by the blue lines here at 12:30. And what they've done is cut off the other seismic events that happened after 3:30. You don't see 4 o'clock here. You don't see 5 o'clock here. They've cut it off. Why? They're concealing information, hiding information. Here we have a 3.0 earthquake happen at 3 p.m. At 3:30, what happens? Right before 3:01 or 3:31 p.m. hits, all of a sudden we have another good-sized earthquake. At least a 3.5, maybe even a 4.0 earthquake. Again, we can't see the bottom of it. However, we can see out to the right. The main part of this earthquake lasted over a minute. Then we have a secondary wave that lasts a minute and a half. And that secondary wave also started a 2.4, 2.5 earthquake, maybe a little bit larger than that. Okay, over here to the right. So we have a secondary wave that lasts a minute and a half. So the earthquake that happened before that had to be substantially larger, a 4.0, 4.5 earthquake at Mount St. Helens. Now let's look at this line here. Folks, are you guys still with me? Can somebody give me a 5.5 or 5 times 5? Let me know that you're watching here, that they didn't cut us off. I think they cut us off. Dadgummit. Dad frickin' gummit. Okay, you guys still are with me. Good. I don't know why they cut me off here. That's ridiculous. Okay, they didn't cut me off here. Okay. I'm still here with you. That's good. Okay. Okay, I want to show you this. This is important. Okay. Mount St. Helens. Okay. They're not showing us everything. They're not showing us everything. They turned down the seismograph. They're not letting us see the damage that was done here. Mount St. Helens is a large volcano. In the past few weeks, we've seen earthquakes here. The earthquakes are continuing. They don't want to report exactly what's going on here, because if the public finds out about it, the public would get outraged, number one. Number two, you would see people fleeing Mount St. Helens in droves. People might be feeling these earthquakes. We don't know because the USGS is hiding the earthquakes on the map. They're not showing anything going on. Absolutely nothing going on. Okay? That outrages me. When they don't show what is going on, they're hiding information. Okay? That's just at Mount St. Helens. Okay? We showed you Mount Hood. We showed you Mount St. Helens. Folks, Let's go down to Mount Rainier. Okay, I want to show you Mount Rainier. Again, the Pacific Northwest Seismic Network. Okay, what is this? Folks, this is Camp Muir. This is Camp Muir, guys. This is the VLF waves at Mount Rainier. How does this happen? Number one, magma coming into the volcano causes VLF waves. That's what we're showing you here. We're showing you tremors here and earthquakes. Now, we know that they've turned the seismographs way down. So what appears to be tremors here might, at the east dome of Mount St. Helens, be larger earthquakes. Or not Mount St. Helens, I'm sorry, Mount Rainier. We just got through showing you Mount St. Helens on that other one. This is Camp Muir, okay? We're showing a great deal of VLF waves. Heavy concentration of VLF waves at about midnight last night. Let's blow this up for you to let you see what's exactly going on here. Okay? Look at that. Actually, this is actually, just about midnight. Okay, the VLF wave concentration starts just before midnight, and it continues for a good part of the day today. It continues almost all day long. Look what happens here. That's from magma entering the magma chamber here at Mount Rainier. So we have a heavy concentration of VLF waves, a lot of magma coming into Mount Rainier. That's unreal. That's unreal. But it doesn't stop there. Okay? That's Camp Muir. Let's go down and look at hold on a second. Okay. This is Camp Muir on the other part of the seismograph. Okay. Camp Muir is a multi-channel seismograph. Okay. On this seismograph, this is the main page on the Mount Rainier mountain. Okay. This is big time. Okay, this is big time. Look where we have the concentration of magma coming into the volcano, the VLF waves. Look what we're showing you here. A heavy concentration of magma here. Okay, we have a bunch of tremors here. But folks, we know the seismograph has been turned way down. What we should be showing you here is a heavier duty concentration of magma here. Thicker lines here at Mount Rainier. But instead of thicker lines, what are we showing you? What are we showing you? Thinner lines here, but a large concentration of magma. Each of these lines are thicker. We know that. If the seismograph had not been turned so far down, we might not see any white at all on this seismograph. A heavy concentration of magma came into Mount Rainier today. It caused a lot of tremors and at least a couple earthquakes. Over here on the left-hand side, let's look at this one. Okay, I want to show you this. over here on the left-hand side, this earthquake happened at 9 a.m. this morning. 9 a.m. this morning. Okay? This appears to be a 2.2, maybe 2.3 earthquake. But again, the top and the bottom of the earthquake have been cut off. This may have been a 3.0 earthquake. We don't see any secondary wave after that earthquake. This may be simply a 3.0 small earthquake. In the very least, it's a 2.2, 2.3 earthquake. Minor earthquake compared to a small 3.0. Also, further down here, okay, after 2 p.m. on the black line over in the center left, it appears we have another 2.2 earthquake. It didn't last very long, maybe a second or two. But we had an earthquake. And the magma persisted. We see magma infill signals here. Each and every line, we see magma infill. Pulsed magma activity, where the lines get thinner and get thicker and get thinner again. Pulsed magma activity here at Mount Rainier. Now, they're not showing us everything. We know for a fact that they're not showing us everything. They never do. Heaven forbid they show us exactly what's going on. Okay? Carl Smith is in the chat. Sorry I haven't paid more to the chat right here. Paid more attention for the past little while. I'm sorry. I'm trying to show you a lot of information in a very short time period. Carl Smith says, us being on cycle 25 has me concerned. There was a video that Carl says he watched years ago with military intelligence that this new cycle would be a problem as well as New Madrid. You better believe it. You can count personally for that to happen. Okay, I know for a fact that's happening. I know for a fact that it's happening. Okay? For us to be seeing this kind of seismic activity and magma activity at any of these volcanoes tells us, folks, that there's a lot more activity going on. There's a lot more activity going on. That's a fact. You can set your clocks by it. It's a fact. We're seeing a lot of heavy-duty magma. Okay? The solar flares are there. The solar flares are going to get us plasma radiation coming here to the surface. We're going to see an increase in magma activity at all of the volcanoes. You can set your watch by it. I guarantee it's going to happen. Okay? We're going to see a lot more earthquakes. We're going to see a lot more volcanic activity. That happens during these heavy-duty solar cycles. Let there be no doubt about what's going on, guys. I hope you have no doubt about what's going on. This is going to continue. Not just at Mount St. Helens, Mount Rainier, or any of the other volcanoes. I'm just showing you what's going on in the Pacific Northwest. It's all the same. USGS can hide information. They certainly are hiding it because it did not show up on the USGS map, which says they're hiding the information. If this was happening, they should be showing us, right? You're darn right. They should be. I just got through showing you 3 volcanoes. I guarantee you, because I've seen the information, I could be here another 2 hours showing you what's going on at the other volcanoes. If I can get to start at a decent hour, I will show you what's going on again at the other volcanoes. I've been having medical appointments. That's why I've been late coming on the air the last 2 evenings. I'm sorry about that. But folks, stuff is happening. You folks that live in the northwestern part of this United States, you should be very concerned. 3.0, 4.0, 5.0 earthquakes are happening under your nose. You feel the earth shaking. It's not a major earthquake. It's not a major earthquake. It's not even a 5.0 earthquake yet. We have seen 5.0 earthquake just 2 weeks ago here at Mount Rainier and also Mount St. Helens. Today, I showed you good-sized earthquake activity at all 3 of these volcanoes. I guarantee you it's happening. If you guys live near any one of these volcanoes, you know that it's happening. You're feeling the movement of the earth beneath your feet. Okay? It's not just a song. It's reality. It's reality. Guys, do you have any last-minute questions for me? Do you have any last-minute questions before we get out of here? I'm not totally quite done here. Okay? I'm not totally done here. Heather's not here because she had some other things pending that she had to take care of. We miss our Heather. But we're here. Demon Catman says, EVO, look into it. Oh, believe me, we're looking into it. And yes, there's plenty of past evidence that supports it. Absolutely. Absolutely. Demon Catman tells EVO to look into it. Yes. It's big time, guys. We can no longer say that nothing's going on. The agencies might tell us that nothing's going on, but their own data tells us a different story. Their own data tells a different story. Any questions here? Grace for purposes, you're doing great, Ron. Thanks. I thank you also for being here. Okay. My buddy Al Sanchez is here saying, thanks, Ron. Good report tonight. Thank you for also being here, Big Al. I call him Big Al. He's a good friend. I can get away with calling him Big Al. Okay? Let me share something else with you, and then we'll get out of here. Okay? Tonight's devotional comes from the New Testament in the second epistle of Peter. Chapter 1, verses 3, 4, 5, and 6. We talked actually 3 through 8. If you'll give me some patience to go through the scriptures here, because I think it's very pertinent with each and every one of us. Let's start in verse 2. 2 Peter chapter 1, verse 2. Grace and peace be multiplied unto you through the knowledge of God and Jesus our Lord. Peter is kind of talking like Paul was in his epistles. He starts off kind of introducing himself and blessing the people. In verse 3, according as his divine power hath given unto us all things that pertain unto life and godliness through the knowledge of him that hath called us to glory and virtue, whereby are given unto us exceeding great and precious promises, covenants with the people. The Lord promising blessings if we obey his commandments. That's what he's talking about. Covenants with the people here. Even covenants with us. Okay? Whereby are given unto us exceeding great and precious promises, that by these you might be partakers of the divine nature. divine nature, meaning being brought into the kingdom of heaven. If we obey the commandments and do what we have told the Lord we're going to do, we'll be able to live in heaven. Live in heaven with our Heavenly Father and Jesus Christ. Okay? Partakers of the divine nature, having escaped the corruption that is in the world through lust. And besides this, giving all diligence, add to your faith virtue. Add to your faith virtue. And to virtue knowledge. And to knowledge temperance. And to temperance patience. And to patience godliness. Godliness. We want to live in heaven with our Heavenly Father. We need to start acting godly, holy in our lives. Okay? In verse 7, and to godliness, brotherly kindness. When you're in the service of your fellow man, you're only in the service of your God. Being kind to our fellow man. And then kindness, we add charity. Charity. We can't have love if we don't have charity. In verse 8, for if these things be in you and abound, they make you that ye shall neither be barren nor unfruitful in your knowledge of the Lord Jesus Christ. By their fruits ye shall know them. The Lord promises us, if we have those traits, we will be looked on as a city on a hill. People will want to follow us. Our example will speak thousands of words. Our example will go before us if we do the things that the Lord hath commanded us. That's what he's talking about here. Brothers and sisters, I bear you my testimony that what we've told you tonight is true. The activity is ongoing. It always has been, and it's getting bigger. Over the years, I've shown you minor activity at the volcanoes. I've shown you minor seismic activity all over the globe, the United States included. Now, all that activity has gotten stronger. We know the end is near. I keep showing you scriptures. I like to talk about wonderful things that can happen to us if we are worthy. That's why I try to leave a devotional at the end of our program. A lot of you want that as well. I want to share that with you. Folks, I love you. I love you. The sun is hopping mad, Betty Zoom says. The sun is hopping mad. There's activity on the sun which is going to lead to more activity here on the earth and everywhere else throughout the system, throughout the entire solar system. It's not just happening here, it's happening everywhere. Now, folks, I ask the Lord to bless you. I want to thank you all for being here with us. We have 123 thumbs up. If you have not already given us a thumbs up before you leave, please do so tonight. We appreciate your attendance here. Folks, if you don't stay the entire time that we're on the air, it almost does you no good because you don't know what we've talked about. If you're here at the beginning, stay to the end. If you're only here at the end, you don't have a chance to see what we talked about at the beginning. And then you have to go back and watch the entire program again. And that's fine. That's always fine. But I'm just trying to give you information that's going to help you prepare for what's happening in your lives. to have a preparedness kit, to have a preparedness plan, and water, food and water. Have a plan, have food and water, have clothing, medicine, and everything else that you might need for an emergency. These emergencies are happening around the globe. I showed you that tonight. I showed you parts of Europe and the Middle East. There's plenty of earthquakes that USGS is not telling us about. They never will. They started cutting us off 6 months ago, maybe earlier than that. They've been doing it for a long time. God bless you all. I appreciate you all being here. Thank you for being here. Thank you for your support of this program, both here in Super Chats. We appreciate everything everybody has given us tonight. God bless you for that. I really appreciate it. We haven't had much activity on Venmo or PayPal in quite some time. I have a dear lady that's sending support on Venmo occasionally. We used to have 2 or 3 or 4 people. We used to have quite a few people with PayPal. That's all stopped lately. We'd appreciate that as well. Guys, when I go to Rumble, they don't have Super Chat. So you guys, if you're going to support me, you're going to have to do it on Venmo or PayPal or send it to our P.O. Box. I went to the post office today. There was no cards or letters. We got one card and a letter from Jan and Phil in California. Remember this? They sent it to us, and I got that last week. I appreciate it greatly. If you want to support us, that's how to do it. Our P.O. Box. It's right there in front of you on the EMA banner here. P.O. Box 422, Valdese, Valdese, North Carolina. Zip code is 28690. Thank you for your support. Thank you for your love. I appreciate everything you do. I want to continue to support you, to put out good, pertinent information. I will be going to Rumble. It's a matter of time. If you guys see me cut off here, you will find me on Rumble for sure. I will be going to Rumble. I have a channel there already, Emergency Management Associates on Rumble. It's been there for quite some time. I haven't used it for some time either, and I'm sorry about that. But I will open it up again. I will be there very shortly. May God bless you. May God bless you and bring you the things that you need in your life. May He help you in all ways. We have quite a few people that are sick and ill at this time, and have things happening in their lives that need the Lord's blessings. One of them is Heather. Another one is Don and his wife. Another one is Rob. He has problems with his shoulder. His doctor's trying to help him. Gina in Hawaii. Gina tomorrow will have 3 years completely straight from alcohol or drugs. 3 years sober, Gina. Congratulations. I just got word today that my Aunt Tina in Idaho died early this morning. Andrew Golden, thank you so much for that $20 super chat. Thank you, my friend. I appreciate you here. Andrew says, good program. God bless you, Andrew. I appreciate you so much. Anyway, my Aunt Tina died in Pocatello, Idaho this morning. Her son, Craig, a very dear cousin of mine, has a daughter that was diagnosed with throat cancer. Cancer is becoming more and more prevalent. So what I'm asking is for everyone to pray for my family. Pray for our individual EMA family here. And also pray for your own family. God blesses us when He hears our prayers. God blesses us. Brothers and sisters, I know for a fact that's true. I've seen it happen in my own life. My life upon the earth has been lengthened because I am doing the things that the Lord would have me do. I appreciate all of you. I love each and every one of you. You mean the world to me. Thank you for being here, brothers and sisters. I hope you have a good night and a better tomorrow. If anything else happens tonight, we'll be back on the air tonight to tell you about it as soon as the information becomes available. Until then, guys, take care. God bless you all. Thank you for being here. God be with you until we meet again. We will see you on the other side. Good night, everybody. God be with you till we meet again. Much love.